Hey, in this video I'll be talking about event loop and how it is taken advantage of in Node.js. First of all, I want to start by saying that JavaScript is a single threaded language, which means that you can only execute one process at a time. So there are two types of code. One is blocking and the other is non-blocking code. So the blocking code is a piece of code which blocks the entire process memory or the call stack. What I mean by that is when the compiler or the interpreter is executing this blocking piece of code, it can't execute any other process at that time. It can't even basically the browser won't be responding because you can't even execute any piece of code until this blocking piece of code finishes. In the case of non-blocking code, it's quite normal because it's the type of code which just executes and comes out of it. It does not block any code, and it does not take up any memory or call stack for a long period of time. So the problem arises, and the part where the event loop plays its role is when we execute blocking piece of code. Because for example, there's a piece of code that's going to block for let's say 10 seconds or 20 seconds. We can't keep waiting for 10 seconds or 20 seconds given the time, so that other processes will be late in that case. If you're going to execute a 10 seconds block of code, then 10 seconds are wasted because it could have been used to process other events or pieces of code. So that's where event loop comes in. That's the job of event loop, is to actually prioritize or reduce the blockage of code, and that's what event loop does. So first I have a diagram here to show what it would have been if there was no event loop, if everything just goes manually. So here there are two console logs. Basically this is a call stack. V8 Node.js runs on V8 runtime, which is the same as Chrome's, and we have this basically this block is a function. The first function contains a log of A, and the second one contains a log of B. So this basically console.logs. So let's see how this goes when it gets executed. So first we call the function A. This goes into the stack, and then we print A, and then it gets popped because the job is finished. And after that, the next piece of code which goes in B, and then it also gets executed. It prints B and it comes out. So that's it. These both are non-blocking pieces of code, and this did not take any time to execute that piece of code. So let's take a scenario here, and if we can assume that if there is another function here which has a set timeout of 10 seconds, which means it delays the function by 10 seconds. So let's see how that goes, and let me put that in between A and B. So we see here, first we execute this, it goes into the stack, it prints A, it comes out, and then the set timeout goes in, it waits for 10 seconds, and in these 10 seconds nothing else is going to be executed, not even this B or any other process in the memory. So it just takes up 10 seconds of our time, and after 10 seconds whatever in the callback gets executed, and then it comes out, and then B goes in, and then it comes out, it prints and it comes out. So this is what it looks like when there is no handling of blocking events. This actually is a serious waste of time. That's why even Node.js was even introduced in order to reduce the blockage of code. So let's see how event loop handles this scenario. So this is how the node environment is going to look like. So the node environment will be having a call stack, and it also will be having a callback queue and a C++ API. So I have 4 functions here. Basically 2 of them are non-blocking and 2 of them are blocking. So what I would like to simulate what it looks like and what's the job of each part of this. So firstly, as you have seen, the call stack is the stack in which the functions are being executed, and the function on top of this stack is the current process being executed, and the queue and these APIs are to handle the blockage of code. Let's see, we have actually seen what happens if there was no handling for blocking events. Let's now see how event loop actually handles the blocking events. So this callback queue is placed here to handle the blockage of events, and there are some APIs which would handle the the blocking events. So our main aim is to keep this call stack free of blocking events, and whenever the blocking event is completed, then we would be sending the data to the call stack, and it would just execute the block. So what I actually mean by that is that, for example, we have console.log here. This is non-blocking, and it just gets executed right away. So console.log is done, and after that we send this set timeout of 10 seconds to the call stack. So it does not wait, or the loop does not stop, or the entire process is not being stopped for 10 seconds. What eventually happens is that this process, the event loop actually sees that it's going to take 10 seconds. So instead of just waiting for 10 seconds, what it would be doing is that it would be sending this to the C++ API. If this was not Node.js, it would be web APIs here. So but Node.js is using C++ APIs, so we'd be writing C++ APIs here. So the set timeout is being sent here, and after for the next 10 seconds it's going to be staying here, and it's going to finish, or it's going to wait for the next 10 seconds. And in that 10 seconds the call stack here is free, right? So there is no blocking of any event right now. And then the HTTP request we are doing, it also goes into the call stack, and it sees the event loop sees that this is also a blocking event. So this also is being sent into the C++ API area. And next the final function here will be executed, and it's just a console log. It just executes right away. So after 10 seconds, or we can say whatever finishes first, in this case let's assume the set timeout finishes first, that is sent into the callback queue here. Okay, that's sent into the callback queue, and then it sits here until the event loop checks the callback queue. Whenever the call stack is empty, then the event loop looks at the callback queue, and it sees if there are any anonymous functions or any callbacks waiting here. In this case we have the set timeouts callback. We don't have the set timeout, we have the set timeouts callback in this queue. So we see this, and it sends this into the stack. And after that let's say HTTP request is finished and we got the response, and we get the callback, and the callback is sitting here. And after this being executed, this goes in. Because the stack is empty, it again checks for the callback queue, and HTTP request, the response we got is sitting here, and this is taken into the call stack, and it's executed, and then it's done. That's it. So in this scenario, whatever happened now, we have actually seen that there is no blockage of code, right? Even though there is set timeout, even though there is HTTP request, we actually finished both of the console logs even before set timeout or HTTP request. If this was not event loop, what would be happening is that we would be waiting for 10 seconds here, and we would be waiting for the response until we got the response in this case, and after that we would be executing the last console log. So the event loop has not blocked anything here, and it's just executing whatever is possible at that moment. So let me show you how this actually works. I have two files here. One is a block, one is block, and the other is non-block. So let's see what's inside non-block first. So we have three functions, A, B, and C, and we are calling them in order A, B, and C, right? So let's actually go and execute this non-block.js, and you can see it's usual because A, B, and C are being executed in normal order. And now we want to look into what's there inside the block.js. So there are three functions, but in the second function we have a set timeout for 5 seconds, which means that this console.log is being delayed for 5 seconds, but we are calling the functions in the same order, A, B, and C. Now let's try to run block.js, and you can see that A and C are being run first, and then after 5 seconds B comes out. So why is that happening? As we have talked about this, because B is a blocking event in this case, and Node.js or the event loop does not want C or A to block because of B. So it just executes whatever is available at the moment, and the B, as we have talked about this, it's a blocking event, so it goes into the callback queue, and after 5 seconds it just pushes from the callback queue to the stack. So that's what happened in this case.